We need something like, I like blue and green. Okay, so this says the radical of 32 divided by 6 is the same as saying radical 32 divided by radical 6. There's no squares in here, but there are squares in here. The square in there is 16 times 2, right? So the square is 4 squared times 2. I'm skipping steps because yesterday we did the middle step, right? So you should be able to recognize squares over root 6. Okay, important part here. You can't have radicals in the denominator. So, how do I get rid of a radical in the denominator? Well, I know that root 2, I'll just use 6. I know that root 6 times root 6 is equal to root 6 squared. Therefore, it would just be 6. So if I know that, if I multiply by 1, I'm still safe, right? Anything times 1 is still itself. Well, what's 6 over 6? 1. So what's root 6 over root 6? 1. So I can multiply this by root 6 over root 6, correct? Okay, so let's do that. So if I multiply by root 6 over root 6, I'm still multiplying by 1. When I do that, I'm going to go ahead and simplify this as well. What gets kicked out of here? The 4. So this is 4 times the square root of 2 times 6, right? Because there's a 6 underneath the square root, and there's still a 2 underneath the square root, and we're multiplying. Follow? Would you rather me have the middle step there? Multiplication means I can go straight across. So I would have 4 root 2 times root 6 over root 6 times root 6 is root 6 squared. Root 2 times root 6 is root 12, but I'm not going to write it that way. I know 6 has got a 2 and a 3 in there, correct? And I'm searching for squares, because squares and square roots are inverses of each other. That's what I'm looking for. So since 6 is 2 times 3, I now have a 2 squared times 3, or 4 times 3, right? Over 6. Did I lose anybody yet? You already there?
Yep.
Awesome. Okay. What else gets to come out? The 2. So now I have a 4 times a 2 times a root 3 over, I'm going to factor 6. 2 times 3. 2's go away. So my answer is 4 root 3 over 3. Then I do this? No, you should be screaming at me right now. Right? You can't do that. Why do we cancel things? You may know. Can you explain to me why we cancel things? Cancel. Why do we do that? Because it's easy? Not because it's easy. I heard it. Because it equals 1. Good job. Right? Does root 3 over 3 equal 1? No, so you can't do that. Only if it equals 1. That's why we've crossed off the 2 and the 2, because 2 divided by 2 is 1. Right? Okay. That won't be your only opportunity. Okay, so let's talk about 3 representations of an imaginary number. So yesterday we talked about the fact that if we looked at this as an area model, and this area was -1, what would the sides be? What's the inverse of a square? A square root. So the sides would be -1 and -1. Correct? Therefore, this is equal to, what's the same thing as -1 using I? I squared. So if this is I squared, what would be its equivalence on the sides here? I times I. Do you see how these two things are exactly the same thing? No? You want me to say it again? Okay. So I told you that the square root of -1 equals I. Correct? So the square root of -1 times the square root of -1 is -1 in here, right? Well, if the square root of -1 is I, then I times I is I squared. This is why because square root of -1 times square root of -1 is the square root of -1 squared. You see that? Now this is exactly why we use I. You see what I'm saying? So a square and a square root cancel each other out, right? Which is just -1. The reason we use I is for that exact reason, right? There. Because we know, our math tells us that -1 times -1, guys, is what? Is +1. So in order to preserve the fact that this is a negative number in here, we no longer use the -1 in there, and we talk about it as being I. Therefore, if you make it a variable like that, it's not really a variable because the variable changes, but if you make it something else, if you give it a different representation, it now has new rules. Right? Because when I know that I squared has its own rule, isn't I the only thing you can square and get a negative number? You see what I mean? Like how that makes sense? I is the only thing in math that when you square it, you get a negative number. Is there anything else you can think of you can square and get a negative number? No. Right? Negative anything times negative anything is always going to be positive. So I has this special quality to it. That's why we give it the letter I. And that's why we call it imaginary. Because it's the only thing that works that way. Okay? Make a little bit of sense? Yeah? Okay. So we have this. I didn't want that here. So we have this representation, and then we have the fact that I showed you the pattern. So I to the 0 is 1. This is I. This is -1. And this is -I. And then now we're going to use these two pieces of information to talk about square roots. So the square root of -32 is -1 all by itself times 4 squared times 2, which equals -1 under square root is I. 4 gets kicked out. So I have 4I root 2. So if you don't want the I out here, if you put it back in here, it would be -2. But we don't normally have that as a representation. Once we get it out of there, that negative 1 out of there, then we can work with it. I has its own properties that we can use. Okay? All right. Does anybody need, this is all kind of review. Can we move on and just start using it? Or somebody want to write this down? No, we're good? All right. No objections. I'm just going to go. All right. So I'm going to solve this. So my first step in solving this, pencils down, just pay attention. My first step in solving this is to isolate the variable. I isolate the variable by subtracting 100 from both sides. By the way, this is almost the difference of 2 squares, only it's not subtraction, right? But if this was subtraction, it'd be the difference of 2 squares. You can humor me on this one? I want you to recognize this. This is the difference of 2 squares. 4 is a square, x is a square, 100 is a square. So how would I factor that? How would I factor 4x squared? 2x and 2x. And how would I factor 100? Minus 10 and plus 10. Just going over that. All right. But it's not the difference of 2 squares. It's the sum of 2 squares. So I'm going to subtract 100 from both sides. Now I have 4x squared equals negative 100. My next step is to take the square root of both sides. Take the square root of this side, take the square root of this side. Whenever we put a square root over something, we have to save our butts by putting a plus or minus in front of it, right? We'll talk about that in a minute. So there's a square there and there's a square there, so this is just 2x equals what? What do you guys think? Negative what? Negative 1 times what? 10 squared. Then what gets kicked out? They actually both get kicked out, right? Correct? Okay, so we're left with 2x. I'm going to take the square out of it for now. 2x equals 10i. Perfect. All right. So what do I do now? Divide by 2. So x equals 5i. Let's go back to this whole plus or minus thing. There's a reason why it's got to be plus or minus. All right? What we're doing is we're solving for an unknown. When I have this, can you tell me whether x is negative or positive? Can't, right? You can't tell me whether x is negative or positive. So because of that, when I take this square root, I have to consider both scenarios, positive and negative. Because if it was a negative, like let's say it was negative 2, when I square it, that negative is lost, right? Which is what we talked about with the whole I situation. So, just to cover ourselves, we have to say that there's a possibility that this is plus or minus, plus or minus, plus or minus. Alrighty. Here's another example. What if x squared equals 25? How do I solve that? Take the square root of both sides. So x equals 5. That was easy? Well, check this out. So 5 squared, putting it in the original equation, should equal what? Well, but doesn't negative 5 also squared also equal 25? So do you see why we need both the positive and the negative? Okay. That's exactly why, right there. Because both work. Both work in that case. All right. I'm going to do another one. Let me give you a chance to copy that one down. All right, now let's move on. All right, find the values of x and y that make the equation true. Looks like a whole lot of stuff, right? Really, really not that bad. All right, so first of all, let's set up the real parts equal to each other and the imaginary parts equal to each other. So what I'm going to do is I'm going to say, well, there's a real part. There's a real part. Here's an imaginary part. And here's an imaginary part. So 5x plus 1 equals 2x minus 2. 3 plus 2yi equals y minus 6i. What could I do over here? Anybody see it? What could I do to both sides over here? Why would you distribute when you could divide? What do both sides have? I being multiplied by something, correct? So couldn't I divide both sides by I? Yeah? Cross them out. Cross them out. This side you just solve straight. Subtract 2x from both sides. And subtract 1 from both sides. So I get 3x equals negative 3. X equals negative 1. Now this one's just 3 plus 2y equals y minus 6. Subtract y, subtract y, subtract 3, subtract 3. Y equals negative 9. All right, write that down. Okay, so now after thinking about it, check this out. You ready for some elementary math? If I were to say so many apples plus so many bananas equals so many apples plus so many bananas, don't the apples equal each other and the bananas equal each other? Right? Do you see it? As long as there's an equal sign in there, I mean, you can't say the bananas equal the apples, but if there's an equal sign, if there's a statement that says equals, it means that this part equals this part, and that part equals that part. Correct? That's all it is, apples and bananas. Okay? Does that help? Thank you. All right, let's move on. Does anybody need this anymore? Or did you guys just all look at this and go, that was easy? It was easy. Okay. No need for my whole visual? Apples and bananas? Okay. It doesn't look easy to me. Okay. So, pencils down again. All right. Let's start with something a little bit easier. And I'm seeing why I wanted to start with this before. Do you guys remember these? Is that in simplest form? Why? Because I've got a radical in the bottom. But do you guys remember that you can't multiply by root 2 over root 2? That doesn't work on this one? What? No, that's not why. Because when I multiply this times this, I have to distribute. And when I distribute, I get 2 root 2 and root 2 plus 2. I still have a radical underneath there. So it didn't work. It didn't help me out. So this, we have to actually use the whole method of multiplying by the conjugate. Remember that? Briefly? Multiplying by the conjugate means I have to multiply both sides by 1 minus root 2. 1 minus root 2. Now there's a specific reason why we have a plus and a minus here. When you're factoring, what does that mean right here? When I have a plus and a minus, and this is something and this is something. It's the difference of 2 squares. When I do the difference of 2 squares, let's change it. Let's make it x plus y and x minus y. Can somebody tell me over here what this would be FOIL? X squared. Nope, don't need all that. Think about the very beginning before you factored it. It's the difference of 2 squares. Brandon? Not plus, the difference. The difference of 2 squares. That means there's always a minus sign in the middle, and it's a square and a square. When you factor it, it's an x and an x and a y and a y. Correct? Let's use that same type of reasoning to do this one. What was this one originally then? Let's try another. X plus 2, x minus 2. What was that originally? X squared minus 4. What's this one? What's that one? X squared minus 1. What's this one? No. 1 squared minus x squared, or 1 minus x squared, right? That's what you have here. Okay. I'm going to FOIL it and you're going to see it. Okay, so when I FOIL this, I get 1 times 1, do first, outer, inner, last. 1 times 1 is 1 squared. 1 times negative root 2 is negative root 2. Root 2 times 1 is root 2. And root 2 times negative root 2 is negative root 2 squared. Correct? If you FOIL it, don't these cancel each other out? So I was left with 1 squared minus root 2 squared. Do you see it now? This compared to this? Let's try another one. How about 2 plus root 4, 2 minus root 4. What will be in the squares in this one? What number, when I split it up, makes 2 and 2? 4. Difference of 2 squares. You see that? I'm just splitting it up. Okay. So when I do this, I get 1 minus, what is root 2 times root 2? 2, which is negative 1. Let's do another one. Top is 2 minus 3 root 2. Let's try this one. Okay, go ahead and write it down. We're going to go step by step together. All right, so let's try the same thing, same strategy, but we've got it with I. So this is really this, right? So we can't have a radical in the denominator. So in order to do that, we need to multiply by the conjugate. So what's the conjugate of 1 minus I? 1 plus I. 1 plus I. I just created the difference of 2 squares. The difference of 2 squares. What's the square I broke up for this one? 1. What's the square I broke up with this one? All right. What about the top? What happens with the top? Do you guys see how I took the 1 and the I and I just put it in there? Yeah? Okay. So let's FOIL the top. 2 times 1 is 2. 2 times I is 2I. I times 1 is I. And I times I is I squared. Here's where the magic happens. Gather everybody up, okay? I've got a 2 and nothing else, that's just 2. I've got a 2I and another I, which is 3 I's, and I have an I squared. But what is I squared? -1 over 1 squared, which is 1, minus, what is I squared? -1. So now I have 2 minus 1 on the numerator, which is 1 plus 3I over negative times a negative is a positive over 2. I want to try another one of these. Does everybody have this copy down? I'll go back. 1. All right, let's try another one with I. 4, you tell me. Make it up. Seven over 4. minus I. You want to try it on your own this time? We'll do this one together and then one more. What would I multiply by to get rid of that I in the denominator? 4 plus I. 4 plus I. Difference of 2 squares. Difference of 2 squares. What goes inside of this one? Guys? 4. And what goes in this one? I. Samantha? Yep. Alrighty. So I've in the top, I have in the numerator 28 plus 7i. In the denominator, I have 16 minus 1, because I squared is negative 1, which is 28 plus 7i over 17. Is it starting to click? You guys are the least vocal Algebra 2 class I have ever had. Is it because it's after lunch? Probably. Yes, sir.
Wait, so if you have a 1 on the denominator,
no. If that's all you have left is 1, nope. All right, let me go back. Are you guys ready? I want to go back and just make sure we've got this business taken care of. Can you set this one up on your own? Go ahead and try it. What are you setting up? Come on, hear me. What are you setting up? No.
Oh.
This one is apples, right? And bananas. I heard apples and bananas. This is what I got. Does it match up? Questions? No? Let's go to our closing thought and start working on some homework. Simplify this for me. What does an imaginary number look like conceptually? An area model, right? Conceptually, what is this area? It's I squared or negative 1. Conceptually, that's what this means. Okay, that's what I wanted you to say for that. Okay, so simplify this for me. So how many I to the 4th do I have in here? So I have I to the 4th 6 times. What's left over? I cubed. I to the 4th is 1. 1 6 times is still 1. What's I cubed? Negative I. All right, let me print that for you. All right, let's do some homework.